Anyone reply?
Not yet.
Some days you are first, some days you are last. Oh, what will we do? You said Andek will be here in...
Yeah.
How long?
He said it will be a bit late.
How long is a bit late? He doesn't say?
Yeah.
Ask him how many minutes. Maybe? No? Did he reply?
No.
Oh.
It's nearly the end. We only have 7 weeks left. So I think we attend every day. That would be great.
Would be great.
Yeah, it would be great.
Where is everybody? Where is everybody?
Sometimes before the end, somebody just get lazy and don't want to attend the class.
I think this is happening. Okay, well, look, it's just the two of us, Chow. We'll start on this, okay?
Half-life.
Half-life. Okay. It's not a lot in the first lesson here. So you remember this formula, Chow? N equals N0 E minus lambda T. I don't know. Were you in class when we did this? You don't remember? Yeah, I'll show you here. So if you have something like uranium 238 and there's radiation coming off of it, then the number of isotopes, you can find it using this formula. And the graph looks like this. Yeah? Does this make sense or not? Are you sure? Yeah? Do you want to write this bit down?
A picture?
Yeah, why not? back. You made it. Come on in. What happened to you?
I woke up really sorry.
Did you draw this, Joe? Yeah. So all we've been saying so far, and is remember we have this formula from radiation. N is n0 e minus lambda t. And we also know from maths class what this graph looks like. It looks like this. This is the graph for n is n0 e minus lambda t. It's decreasing exponentially. There's a picture of it there. So what's interesting about this graph is that the time required for half the sample to decay is the same regardless of when we look at the sample. Let me explain. So let's look here. At the beginning we have 100 moles. 1 second later we have 70 moles. Then we have 50 moles. See, it's decreasing. Yeah? Now, if I start at 100, how long until I have 50?
2 seconds.
2 seconds. Fine, fine. If I start at 25, how long until I have 12 and a half? How long do I wait?
2 seconds as well.
2 seconds as well. Do you see what I'm saying? That no matter where you start, even if I start here, it takes 2 seconds to get half of it. So, if I start at 8, then it takes 2 seconds to get 4, to get half of it. Okay.
Yeah.
This is.
This applies to all of them.
Yeah, all of these graphs have this feature. Now, it's not going to be 2 seconds for every graph. It'll be a different time for each graph. But the idea is the same. So I think what you could do in your notes, after you draw this, just write 2 seconds for half, 2 seconds for half. You know what I mean? Underneath it, yeah.
Yeah.
Are you sure? Okay. So this gives us our first definition for this morning. The half-life of a radioactive sample is defined as the time required for exactly half the sample to become non-radioactive. So imagine, for example, you have 100 grams of uranium-238, for example, and it's radioactive, of course, so there's radiation coming off of it. After some time, what will happen is only half of it will be radioactive. Like in my picture here, my table. After some time you'll get half radioactive. Yeah? So we say that the time you have to wait to get half non-radioactive, radioactive, we call that the half-life. Do you understand the idea?
Yeah.
You might have something similar in chemistry, I think. You have this idea where the time for half a reaction to become...
For the time?
Yeah, you have this thing in chemistry, don't you? Like,
I don't think we covered it yet, but
yeah, like you have some reaction,
yeah.
and there's some time it takes for half of it to finish, or something like this. I don't remember. It's an idea that you see in physics and chemistry and things. It's the time for a process to be half finished.
I just studied this before briefly.
You did, yeah. So you are happy with the idea?
Yeah.
Chow, you got the idea?
Yeah.
Are you sure? Okay. So like a silly example is if you're eating a sandwich, the half-life is how long it takes you to eat half the sandwich.
Yeah.
You know? You see this in biology, chemistry and physics. It's an important idea, the time for half of something. Okay? Alright, so if you can write this down. What are you doing in chemistry at the moment?
Chemistry, we're currently doing. This is a lot of different things, but we're currently going on alkenes and alkenes, your alkenes and linear.
Do they have reactions in them?
No.
No.
Yeah.
Okay. Okay.
It's just basically why it's more reactive from like. Yeah.
Okay. Okay. Right. Now, so what I want. How's your maths? Are you good at maths?
No.
What kind
No.
of things?
Well, I'll give you a simple maths problem. We have this formula here, okay? And let's imagine we start off with n0. And I want to know what's the time taken so that I have a half n0. Okay? So here I have n0 over 2 equals n0 e minus lambda t. I want you to find t from this. Find t. You think you can do it? Give it a try, maybe? You'll make Joan very sad if you can't do it. Because I think you did this in semester 1 when you studied exponentials and logs. Oh, really? If you give me your maths book, I could even show you the page. You got your maths book?
You teach maths as well?
Yeah, this is my book. I made it.
So inside have a lot of Stephen questions.
All Stephen questions. See? This lesson. This lesson is like that one. Where you have to... Yeah. Yeah. See? Remember how to do those, Chow?
No.
Antek? Okay, will I do it, or do you think you can try it? What's your feelings?
Yeah, maybe try to see.
Okay, all right. So the first thing I'll do is I'll cancel this and this, because they're both n0. So now I have a half equals e minus lambda t. Now, what I'll do next? Yeah, good. ln. So they cancel. So now I have log a half equals minus lambda t. Okay? Now, I'll change this into log 1 minus log 2 equals minus lambda t. That's using the second rule of logs. You know, log a over b is log a minus log b. Log 1 is 0, so I get this. So finally, I have my answer. The t, the time for half, is equal to lambda over log 2. Yeah, I think it's good if you can write this example down. So where is Kim and Siba and Matt?
I have no idea. I texted them earlier saying that if they can let you know that I'm going to be late. Turns out they're not even here.
Are they even awake is the other question.
I don't think so.
Because you didn't get a reply.
No, I didn't get it from him.
Yeah, well, he was here first.
Telling them to.
Yeah, he was still late, but he was here first.
You want me to text them?
Ah, no. It's so sunny in the morning. I don't know why. It should be easier to come to school on a sunny morning.
It's not really cool. That's
Yeah.
It's easy to wake up,
Yeah, I think so.
and after that you can't sleep also.
You got that? Yeah, continue? Yeah, okay, good stuff. So we got our formula. Right. Just one example, because it's kind of easy. I think we can do this one together. So, have you studied this in chemistry? C14. Have you studied this in chemistry? No. But do you know what C is?
Carbon.
Carbon, yeah. Now, what should be the mass number of carbon?
16.
Is it? I don't think so.
Yeah.
You can check your periodic table?
Yeah.
No, it's okay. I'll tell you. I think it's 12, I think. Isn't it?
Oh, it's 12. Yes.
12, yeah. I think so, right?
Yeah, it is.
Yeah. So, this one is called an isotope because it has 2 extra neutrons. Good. So you know this idea.
Yeah.
Now, we say it has a half-life of 5,730 years. That's really long. So that means if I have some carbon-14, there's radiation coming out, alpha, beta, gamma. It'll take 5,000 years for me to have half of it. So it decays slowly, very slowly. Okay? Does anybody know why this is important? Andek or Chow? The carbon-14. What's so important or interesting about it? Have you ever heard of it before?
Is it because it has
Yeah?
to react with other?
Not because of this, no. Now that might have something to do with carbon-12, I'm not sure, but it's something special about carbon-14.
Because the bond?
What about the bond? No. Do you know?
It has extra neutrons. So.
Ah, yeah.
Yeah.
Well, why is that so great? So, did you ever hear of something called carbon-14 dating? You never heard of this? Okay. So, everything that's alive, everything, you, me, your food, everything has carbon-14 in it. And when you die, this carbon-14 begins to decay. If you measure how much carbon-14 it has, you can know how old it is. So, for example, if you find an old book, what's book made? What's a book made of? Paper. And where does paper come from? Tree. So a book is a dead tree. If the carbon-14 in it is half of what it should be, then you know the book is 5,700 years old.
Also, it's carbon dating.
Yeah, carbon dating. You've heard of this,
Yeah.
where you can judge the age of something. Have you heard of this before? Or is this new? You've heard of this, Andek, this carbon dating. Have you heard of this?
Maybe.
Yeah. Do you understand the idea?
Yeah.
So, this is how we can tell how old, you know, on TV when they find something, like old, ancient people, this is how they can know how old they are, because of how much carbon-14 there is. Yeah? So, the first question, I think, is no problem for you. Can you change this into seconds? Because we should use seconds. Yeah. Big number, isn't it?
Yeah.
What did you go?
I mean, I'm not really sure if to get seconds because it's a year.
Yeah, well, it's 5730 times 365 times 24 times 3600.
1.807 times 10.
Good. Okay, B. What is the lambda? The lambda. So you can use the formula half-life equals log 2 over lambda. So therefore, lambda is log 2 over the half-life.
Lambda over 1, 2.
Oh, sorry, I have it the wrong way? I thought it was this way.
Yes.
Oh, sorry.
Oh, it's there.
Oh, I'm so sorry. This is wrong. Thank you, Chow. It should have been log 2 over lambda. Oh, how embarrassing. Okay, so what's the lambda here then? Thank you. Okay, C. 1.209.
Yeah.
Thank you. C. The molar mass of carbon-14 is 14 grams. So that means 1 mole is 14 grams. Okay? How many moles are in 100 grams? Press C when you're ready. About 7. Yeah, what is it exactly on your calculator?
7.14.
7.14 moles. Okie dokie. D. Carbon-14 decays into nitrogen-14. In a 100 gram sample of carbon-14, how long until you have 25 grams? So, you start off with 100 grams, then it becomes 50 grams, then it becomes 25 grams. How long will that take? Well, it will be 5730 times 2. So that's like, what's that, like 11,000 years?
460.
11460 years.
Yeah.
Yeah? Okay. Lastly, how long until you have less than 1 gram? Okay, let's work this out. E. So you start off with 100. Then what do you have next? 50. And how long did that take? 5,700 years, yeah. Next? 25. Next? 12 and a half. Next?
6.25.
Yeah. Next?
3.125.
Yeah. Next?
1.5625.
Is it? 1.5.
1.565, yeah.
Good man, Andek. Good man. And wait, now you don't need to type this in because obviously the next one is less than 1 gram. Obviously. So that's 1, 2, 3, 4, 5, 6, 7. It will take 5730 times 7.
40110.
40110 years. It'll take 40,000 years to go from 100 grams to less than a gram.
Yeah.
So, like I said, decay slowly. Okay. Do you need to write this down, or were you writing it down? Chow, do you need to write this down?
B is lambda equals
1.209. You got that? Is okay?
Yeah.
Are you sure? So this lesson isn't so difficult, right?
No.
You only really have one new formula for half-life. Yeah. Now, can you remind me, did the timetable change? Like, do we always have class at 9 o'clock, or are some people thinking they don't have class until 10 o'clock? Is that possible?
I mean, there is a change in the timetable.
Yeah, but then, yeah,
Today is like
It's- it's like last week. You're still in at 9 o'clock,
yeah.
so that can't be the reason.
No, I don't think so.
I was hoping that maybe people thought that.
Only difference is that we're in a different class now.
Only Tuesday. Only Tuesday we have 9 o'clock physics.
Oh, okay.
Yeah. Others,
Tomorrow is
chemistry.
No, don't we have? Oh, not on Friday.
On Friday.
Friday we
On
have.
Friday.
No, maybe not this week.
Afternoon.
It's changed, I think, for this week.
I think this is going to be Friday.
This week we don't have Friday class.
Well, what does it say?
Afternoon.
Yeah, no, what I'm saying, Andek, is we normally had it at 9 o'clock on Friday, didn't we?
Yeah.
Yeah, but now we don't. It's
No.
afternoon.
Afternoon.
So what do you have at 9 o'clock on Friday?
Chemistry.
Ah, it's much better. Okay, right, let's have a look. So, I think what we'll do, let's see, is 9:47. I'm sad that I'm missing 3 people. But we still just need to continue. So look, why don't you try these questions for 10 minutes? Or if you need to go to the bathroom, that's fine too. And we'll do the next lesson at 10 o'clock. And maybe we'll have more students by 10 o'clock. Did you get any reply to your WhatsApp?